I remain, as was mentioned, I remain involved with Eiffel Software, the company that I co-founded in '85, so, which devotes all of its activity to promoting tools, services, to training and so on around object technology, and particularly Eiffel. We're selling the Eiffel's, well, promoting the open source version and selling the commercial version of Eiffel Studio. They're the same code, but the license terms are different. And my third affiliation on the right here is ITMO. ITMO is a national research university in St. Petersburg, so not too far from here. No, St. Petersburg, Florida, but St. Petersburg, Russia. They've made a name for themselves, in particular, by winning 4 times the ACM International Collegiate Programming Competition, last time this year, where actually one of the members of the team is in my group, and they are boosting their research activities. So they have I'm there a few weeks a year, well, a couple of months a year. And we're building a software engineering laboratory, and the work is pretty closely connected to what I do in Zurich. So I'm going to. So I have like 753 slides. So the real plan is, I talk as long as I'm not cut off. That's really the structure, the real structure of this talk. But the theoretical structure is that I'll start with a few general observations about Ada and Eiffel. Then I'll go into some fairly basic stuff. So there are probably slides that Ben and others saw like 22 years ago in acetate form, but actually the basic concepts are still the same. I'll talk specifically about documentation, then about testing, then about inheritance, then about exceptions, handling normal cases, and then I'll conclude like around midnight or so with a few new developments and an attempt at a conclusion. So general observations about Ada versus Eiffel. So I was fortunate to know Jean Ishbia fairly well. I cannot say I was a close friend, but he was a good friend. And actually I also kept the contact with him after his Ada period, when he was doing this very interesting Filati project in the US. Actually, this is, in fact, when I met him most, which is kind of paradoxical, because we were both in France in the 70s, but I was not involved in the design of Ada. I think I don't know why he didn't ask me, but we were in different groups, and actually I was fresh out of school, so I think he felt I was too much of a greenhorn, or maybe we disagreed too much on language design issues, although we agreed on many others as well. So what I do remember is that when the first design came out, the first 4 designs, I'm sure you're all familiar with the history of Ada, so they were red, green, blue, and yellow. So I was part of the French equivalent of SIGPlan, the programming language group, and we were one of the, subset of which I was not a member, was one of the groups that the DoD asked to review the candidates' designs. And what is really funny retrospectively is that, I was the young guy that people kind of talked down to me because I was just fresh out of school. And so, all these people who are really knowledgeable were saying, well, everyone knows that this whole thing is a show anyway, because the yellow design is the one that is a sure win. The yellow design was into metrics, I think. In any case, it was the one where the consultants were Tony Hoare and Niklaus Wirth. And again, this is, I'm sure the younger people among you also know some of the history, but what was a bit special then was that on Ishbia's request, the DoD had demanded anonymity from the designs. But in reality, the yellow, I think it was the yellow team, had cheated horribly by having references of the form Niklaus Wirth personal communication. So, in the bibliography. Well, okay, Tony Hoare, C-A-R Hoare, personal communication. So this was just a bibliographical reference. But of course, like I say, since everyone knew who was consulting for whom, it was not that hard to guess. And so this was really a way of cheating by saying, well, look, there's all these Europeans, they eat garlic and they go on strike. So, are you going to trust Frenchmen? And so, trust the real guys. And so that was the mentality, right? This was the Weltanschauung. This was the mindset. And I looked at the designs, and actually, I thought the yellow design was not that great, and the green looked much better, but no one asked for my opinion. So it was quite ironic to see that the DoD actually had seriously applied its own criteria and made the decision on I think on an objective basis. So I should say that there's a lot of commonality between Ada and Eiffel, but also there are many differences, and the commonality and the differences are somewhat related in the sense that at the time Eiffel was designed, Ada was really the main game in town. So there's always a foil at a particular point in time. There's always the dominant player, and whatever you do, if you're trying something new, you always compare it, you always shoot at the dominant leader. I mean, in the IT industry as a whole, it used to be Microsoft, right? A favorite sport to bash Microsoft. Now it's, I guess, someone else. But at that time it was Ada. So there's definitely, if you look at the early Eiffel literature, there definitely here and there, some ironic remarks about Ada. So on the other hand, you take this, which I took from an introductory page about Ada. So a few of the examples I'm going to show are probably, well, as Ada experts, you might think they're unfair, but I understand the difference between the language design and what you find in textbooks, right? But still, you have to find examples somewhere. So basically, to turn this into Eiffel, you remove stuff, right? So this we don't know, it's noise. This we had, the is we used to have, and then we removed it because someone said, why do we need this thing? It's just noise. The comment at the end, we also used to have it, actually in Ada it's not a comment, but in Eiffel we did not have it as part of the language, but it was kind of a recommender style convention. Have a comment at the end, n dash dash if, the comment convention is the same as in Ada, dash dash, n dash dash if, or in this case, n dash dash name of the routine. What else? Well, actually, all the arguments in Eiffel are in. This business of a routine messing up with the environment of its caller. No, thank you, that's not for me. Thank you very much. Return, well, yeah, it's something like return, but we don't need that keyword. Yeah, it's the same thing here. We don't need any of this. Well, and the exception when others then arrays, well, okay, it's not, I realize this is just a kind of hello world example, but why would I specify an exception handling for something that first is not really likely to produce an exception, and second, this I think is the default behavior anyway. If you get an exception and don't handle it, you just pass it on to your caller. So this we can get rid of. And the part I like best in this example, but I don't know how representative of actual Ada style, so I don't, yeah, but natural, so there's something known as one. So sometimes a cigar is just a cigar, right? So sure, natural, so anyway, this is the way we would write it in Eiffel. For, of course, it's in a class, so we don't need to say stack. And then there's certainly no return. This is the absolute evil. This is the business of returning from deep into the middle of routine. That I understood as soon as I read Dijkstra around 74 or something, also 72 or so. Well, do instead of begin. Those are small things. But apart from the differences, what I think is also very telling is the similarity of the general style. And at one point, Eric Raymond, the Cathedral and Bazaar guy, published a posting where he characterized Eiffel as a bondage and discipline language. And I think, well, I don't think that's true, actually. It's certainly, Eiffel is very much for expressive power with protections, but to a certain extent, to the extent that it's a complement, I would say that we share this complement with Ada. I have a little problem. Give me just a second. Sorry, look somewhere else to think about your boyfriend, girlfriend, grandchildren. Okay, you can look again, if it comes back. Sorry for this. So I was saying that at that time, at the time of the design of Eiffel, Ada was very much the reference, and as an example of this, which today I find really funny, at the time I didn't, when I published my paper on design by contract, which was eventually published by IEEE, when I submitted it in '86, it languished for 6 years in the refereeing process of IEEE computer. 6 years, remember 6 years ago, right? Remember the economy 6 years ago. So it's a long time, it's more than the Second World War. And talking about the Second World War, this is completely unrelated, but it's really kind of impressing and intimidating to be speaking in the Wallenberg room. I understand that this is the Wallenberg room, and that's my absolute hero. End of latest digression. So the paper found itself. This is my personal history. It's somewhat naturally related to this talk, but it explains the context of this particular referee comment. So 3 referees said this was the best paper they had ever seen in their lives, and 3 referees, there were 6 altogether, said this was the absolute worst paper that they had ever seen in their lives, and how dare someone submit something like this to a serious journal. And so the editor-in-chief didn't know what to do, and that lasted for 6 years, and then in between some things had changed. So someone asked me to provide a paper, an invited paper for a special issue of IEEE Computer in '92. And I took my paper, I sent it, I made sure that these typos, there were 2 or 3 typos that I knew about, I made sure that they were preserved, so they're still there in the published version. And this paper has 1,700 citations on Google Scholars, so I think it was not entirely unjustified to submit it. But this, in the meantime, I hope you may have looked at what the referee wrote, and what's really relevant to this discussion is that basically, even though he didn't even know that ADA was not an acronym, right? This is I guess the American with Disabilities Act or something like this. But apart from that, this was very much the spirit of the time. If you have some idea in programming, just add it to ADA. Never mind that ADA was not supposed to be subsetted or supersetted at the time. Just add a few verbs, couches improvements, even if it has to make up new verbs, whatever that is, in the process. So the point is not so much stupid referees. I don't think I need there's anything new there, but it's how much ADA was dominating the scene intellectually at that time. So as another example of this, now I'm going to, I don't know how many people are offended with this. I published this book in 1990. And I had an example language to illustrate the notational semantics, axiomatic semantics, abstract syntax, and so on. And that language called GRAL. And what does GRAL mean? It's an acronym. Great relief after ADA lesson. So actually, the ADA bashing was kind of Microsoft bashing 5 years ago and Google bashing today. It's the kind of the natural thing to do. You take the leader, and if you want to bash at someone, that is the leader that you're going to use. So at that time, I was already, when I said that Eiffel was designed partly after ADA and partly against ADA, this is really a big part of the definition of Eiffel. So there are things which I really didn't like. This is actually from a textbook by my good friend Sabaina Saib, so I think I can cite it. We meet at the farmers market in Santa Barbara, and she still talks to me. And she's seen this kind of. So I was seeing this kind of thing, and I thought, well, we can do better. So this is an algorithm that tries algorithm 1, and if it fails, it catches the exception and it's going to try algorithm 2, and if that fails, it's going to try again. Okay, so I was designing the Eiffel exception handling mechanism at the time, and well, I don't know. I thought this kind of thing is so much better. It's clear, simple. I mean, we don't have go-tos all over the place, and so. And this brings me to the last part of this introduction. This is today, although I'm sure it was written like 10 or 15 years ago, but it's still there. It's in the ADA frequently asked question page. Comments by Tucker Taft. Well, isn't Ada less elegant than Eiffel? I think the language has a number of inelegant aspects. For example, exception handlers only at the top level of routine, with the only way to handle an exception being by retrying the whole routine. So this is a difference of appreciation. I personally think that well, you won't be surprised, but I think that the Eiffel mechanism is much more carefully thought out. Because it's, if I ever get to that part, I'll explain the methodological background behind it, but it's this idea that an exception is not just a control structure that you use freely like an if then else or like a loop. It's a way to handle exceptional cases to which you resort only when you don't have any other choice, when you have your back against the wall and you're really trying to find a way out. And so this is the reason. I'm not saying that the ADA exception mechanism is wrong. It's just that behind the Eiffel mechanism, which indeed makes it possible to handle exception only at the top level of a routine, there's a very carefully reasoned rationale, methodological analysis, and maybe Tucker misses. So no way to return from a routine in the middle. Well, you know, it's like working with, I'm going to be impolite, right? But I probably already have been. Now, yeah, regarding politeness and impoliteness, let's just accept that we're between friends here, and between friends we can talk frankly. And my respect and admiration for Ada are, I hope, clear. They don't require me to sing the praises of every aspect of Ada, otherwise I would be maybe on the other side of this room, a member of the ADA community, which I'm not. So this is a little bit for me like like someone who sees you working with Arabic numerals and who is still doing multiplications with Roman numerals and criticizing you because the digits are not very pretty, right? I mean, it's much nicer, you know, the big X for 10, it's much more elegant. That's the way I see it, right? In particular, what I think is missing completely here, is Tucker in the audience? Or? Yes. Okay, good. You know, this whole business that Dijkstra and others had introduced of, you know, saying we need to work with one entry, one structure. Howard Mills was also very strong about this. It's not just for elegance, it's also because that's what you need to reason about programs. And in particular, in the example that you cite of searching through a list, well, the only way I know to get these things right, these kinds of programs right, and sometimes they can be really tricky, is to have a loop invariant. And as soon as you make it possible to have go-tos, even these go-tos are called break or, you know, they're disguised in various ways. As soon as you have these, there's no notion of loop invariant and no way to reason formally about programs. So it's not just, you know, maybe it's a nuisance to have to use an extra Boolean variable, but I think it's well worth it. The goal is to be able to reason about programs. Namespace control, well, this is, I would say the jury is still out. Personally, I haven't not seen really satisfactory to me high-level package constructs in programming languages, but I think there are arguments back and forth. This one, the first one, the obscure notation being used for an important, well, this was true like 2 years, and so it is absolutely correct. This was an ugly notation, and we quickly fixed the notation. So now the way you create an object in Eiffel, I'm going to make this bigger, sorry. I mean, you say something like create X, which I don't know what you're saying, but in terms of clarity, I think it's reasonable. It's reasonable. So yeah, this was true, but it's like 15 years ago, and maybe it's time to update the ADA FAQ there. No way to conveniently use another structure without inheriting from it. So this is again a different view of the world. That is, the idea in IFO has been to have inheritance made into a very general mechanism which covers both subtyping and implementation inheritance. And everyone thinks this is a horror, but in fact it works very nicely, and it's certainly much better now than it was at the time this text was written. I think it really dates from the early 90s. The different kinds of inheritance are much better delineated now. There's something called a non-conforming inheritance, which does not permit polymorphism. So, yeah, this is a different view. Same thing for this. I think we could argue on this point. No separate interface for an abstraction. You can view an interface by running a tool. So this is, again, a fundamental difference. But the IFO mechanism there was designed after very careful examination of the ADA mechanism. So personally, what I don't like about the ADA stuff, I think this example is pretty typical. Well, to me, the absolute enemy of quality in software, especially in the long term, is duplication. And I think we can say with some certainty that one should never duplicate software. Never. Okay. Now that's a bit extreme, but I think it's true. So as soon as you have the same information appearing twice, then you run problems of evolution. You run into the problem of how to change, how to make sure that the change is reproduced, is carried out everywhere. So the way it works in IFO, as Tucker correctly indicates, is that you write everything once. This was an example for it later in the talk, if I ever get there. Yeah. So the way it works in IFO is that you put everything at the same place, and then you have all kinds of views which you can use to. Well, this was not the one. What did I do? Okay. Then you have all kinds of views, such as ancestors, descendants, clients, suppliers, and then things like the one that he's referring to in this text, the flat view, which has everything with inheritance. And sorry, there's not enough space on the screen, but and in particular the contract view, which is the abstractor view, which is essentially the equivalent of what you get with the package interface in ADA, except that it's extracted from the code as opposed to being written separately. And I believe this is a much more effective approach. Of course, I realize that I'm like telling the General Assembly of Coca-Cola shareholders to switch to Pepsi, but well, one can always try. So, when obviously, there are a few points on which Tucker and I diverge, but actually, I think this particular text should at least be updated, because there's a mix of points on which he's right. I skipped it, but the point about intervals for arrays, I think this is justified. I don't think the ADA solution is there yet. I think the solution is what is being done now with built-in proof tools. Like we're starting to have, because in ADA you can still have runtime exceptions if you're adding, if you're going out of a range. So it's still a runtime problem. It's not that much better than having preconditions. But still, the idea of having special ranges for array indexes, range types for array indexes is good, and it just doesn't fit in the object-oriented framework of IFO. So that a couple of justified comments. Some comments which are really matters of some comments which are just plain wrong, which misunderstand the design goals, the design rules behind IFO. Some comments which are matters of opinion, okay, and well, a few that I've cited, and then some comments which are just no longer applicable. So at least for those, I would appreciate if this text was updated. Just to finish this part and mention how much respect I've always had for ADA. This is a citation from a paper of 12 years ago in the first Wade Harriman Symposium for Tony Hoare. I wrote a paper on language design and evolution, in which I cited something that probably most of you have never seen because it was in French. That more interesting is the answer. So it's about the question of how big languages should be. And Ada was being criticized as being too big. So Jean-Yves Biard gave this answer to the journalist who at the time of Ada's original publication asked him what he had to say to those who criticized the language as too big and complex. Small languages, he retorted, solved small problems. And I think this was a pretty good answer. Of course, at that time, people were throwing Pascal at him. That was, and certainly, you know, if I had to choose between Pascal and Ada, I think it's pretty clear. Yeah, and even back then, you know. So, you know, this shows how much respect I have. Now, I do think that from the evolution of Eiffel, which is not as long as that of Ada, but it's getting, you know, it's already 25 years, so it's starting to be meaningful. There's a few things to learn for Ada. It's possible to improve a language consistently over a quarter century. We have demonstrated this again and again. A standards committee can work effectively. People deride standards committees, but in fact they can work very well. Evolving does not mean growing. So this is something that we retain from the small is beautiful school, even though we don't embrace either of their views. It's that a language must remain simple and consistent. So in particular, what we have done with Eiffel is to remove stuff. Okay? It's very hard to remove stuff because you have an installed base, you have people who are concerned about compatibility, but if you do it right, you know, if you announce what you're doing, if you explain why you are doing it, and if you provide enough advance notice, of course, and provide a migration path for users, tools, whatever is needed, then it will follow you. That's the right way to do. So when you have made a mistake, when you realize that a language design decision was not the right one, just fix it. Just fix it, do it rightly, but go ahead. And major improvements are possible. One of the things that happened in Eiffel in recent years is the business of void safety. This was a major change. It's almost a revolution, this idea that you don't have no pointer dereferencing anymore. You know, when you do x.f, it is statically guaranteed that x cannot be void, as it's called in Eiffel. No. Okay. So this is, of course, a major change. It's almost completed. I would say it's basically completed. There's still some code to adapt to void safety and a few mechanisms to fine-tune. Another one is agents, which means functional programming elements, like in Haskell or languages or Erlang or languages like that, but closely connected with the object-oriented structure. I remember a comment of Jean-Yves Biard at the ICSI conference, software engineering conference in Munich in '78, so this is really, really old. People were criticizing him because there was no way to pass a routine as an argument to another routine in Ada, and he was saying, well, I'm telling these people, there are other ways to do the same thing. Well, that's true, but in the end, you do want, even in a language like Eiffel, which is much more dynamic in this respect because it has dynamic polymorphism and dynamic binding, even so, you do want, for example, for event-driven programming and many other important applications, the ability to have objects that represent behavior, not just data, but behavior. And this is what agents are about. They have also dramatically changed the Eiffel programming style and design style. They've been devised very carefully so they don't, contrary to what we feared, they don't conflict with other mechanisms in the sense that we know when to use agents, when to use, for example, dynamic binding. And of course, the most recent development, which is Scoop. And finally, stick to your guns. In the case of Eiffel, there are a number of fundamental rules. For example, one good way to do anything, you know, we don't want to provide different ways to do the same thing, at least reasonably to do it. Object orientation, abstract data types, which is the same thing, a broad use of inheritance as a fundamental tool, software engineering principles, which have been described in depth in my books, in particular, the open-close principle in others, and of course, design by contract. So, you know, stick to what really makes your approach unique. Okay, so I'm already desperately late, but I'll just speak faster. I think I'm speaking a little slowly. Is there anyone falling asleep? No, so, okay, I'm going to try to accelerate the pace. I only have like about 722 slides left. So design by contract, so very quickly a kind of review of the basic ideas. It's basically a way to make yourself socially absolutely unbearable by always asking the same question, so people go away from you, which is good. I mean, we're all nerds. That's the reason we went into computers, so we don't need any social relationships. And this is very good because you make yourself an absolute bore in all social situations. The ideal for a computer scientist, you keep asking the same three questions. What does it expect? The answer is known as a precondition. What does it promise? The answer is known as a postcondition. And what does it maintain? Yielding class invariance. And these ideas have applications throughout the life cycle, the analysis, design, implementation, and inheritance, exception, maintenance, and so on. The basic idea is so clear that I will skip it. But I'm sure I'll let you read the slide. Okay? Good. And we can use these ideas in lots of different ways. The applications at the bottom right are those assuming that we can actually evaluate contracts, that they are not just comments, but that they are elements of the code that you can actually monitor at runtime. Now, what's conspicuously absent from this list is what is becoming the most important application of contracts today. I would say the second decade of the third millennium. It's proofs, because verifying things dynamically is great, but if you can do it once and for all at compile time, it's even better. And that was always clear in my mind and in the mind of the people behind IFO. And what has changed is that the technology is starting to be there to make this possible. Static proofs. Look at tools like Boogie from Microsoft Research, and this is what I spend my days on, trying to make sure that the stuff can be derived, can be checked, verified statically, and not just dynamically. So this approach yields a whole style of programming, and in particular API design, which is quite different from the standard one. Here's an example from a paper that I wrote with Karine Arnoux a few years ago, which contrasts the, in this case, .NET C# style of specifying an API, basically by saying this routine is going to do something useful, and the way to know what is something useful is to find out what the exceptions are. Then you understand what it's trying to do. Well, in the same routine, doing the same thing, in IFO, remove all items from an arrayed list. It has a precondition and a postcondition which express much more precisely what's going on. I'm not into the sadistic mode today, so I don't think I'm going to talk much more about Ariane 5. I'm also not in my formal mindset Stimmung today, so I think I'll skip the horror stuff as well. I'm not in my social responsibility Stimmung today, so I think I'll skip the comparison with human contracts. But I'm also not in my non-contract programming, not contract-based programming mode either, but still to show you the remains of the past. I'll quickly mention this particular class text, which is one that I've used again and again in introductory presentations because it's convenient. It's a bank account class with a notion of minimum balance, 1,000 Swiss francs, but the fact that it's a constant is just keeps it simple. And then routines of deposit and withdraw, which do what they're supposed to do. And so this is a class which doesn't have any contracts and which actually does what it's supposed to do, add and withdraw and so on. What is, so from a traditional mindset, from a traditional viewpoint, is completely satisfactory. From a more advanced viewpoint, it's completely wrong because there's absolutely nothing in the class text that defines what the class is about. I mean, it's all implementation. So the second version does bring in the actual semantics. For example, the fact that when you withdraw an amount, this amount should not be too small, shouldn't be negative, but it should also not be too big, otherwise we would go below the 1,000 francs. So that's the precondition. And the postcondition stating that the new balance will, as a result, be decreased by some, which naive, I mean, people who see this for the first time, that's still the majority, I would say, usually naively answer, but will naively remark, why do we need this? Because there's this add of minus sum in the body, which does the same thing, right? So, and this is exactly the crux of the issue here, because it's not the same thing. One is implementation, the other one is specification. And there are all kinds of reasons to separate the implementation from the specification. One of them, for example, in an object-oriented context, being that with inheritance you might have many different implementations of withdrawal in descendant classes. For example, one that is for a savings account version or a money market account that actually accrues interest or saves information into a database, makes a record somewhere. And so here we're not just describing what's being done specifically in this particular implementation, but we're defining conditions that will be incumbent on every redefinition now and forever still to observe and maintain. Okay? And of course the class invariant, which was conspicuously missing in the previous ordinary version, meaning that the class text misses the most fundamental semantic property about this notion, which is that the balance should remain over 1,000 francs. So this is kind of the basics of the ideas, which of course have been there for a long time. I'll come back to this example in just a few minutes, so I'll skip it. This is actually a pretty good way to make sure you cover all your slides. Right. So this, here's a second version of the class in which we don't just keep the balance, but we also keep a list of deposits and a list of withdrawals. And you see here, I hope you see how critical it is to have the contracts to help you make sure that you can, for example, play with different implementations. What I'm putting here in a class invariant is that the three values must be compatible. That is to say, the balance, what we find in this field, must be the total of these deposits that we find here minus the total of the list of withdrawals. So what this makes it possible is to play with different implementations. Because, for example, I could decide not to store the balance. After all the information is in the deposit and withdrawals list. And then the balance can be computed. But by the way, since we can all indulge in a bit of C++ bashing together, I think here I'm on safe grounds. You know, what's really scandalous in languages like C++, Java, and such, is that in one case you need to write things like this, and in another one, if it becomes a function, you need to put these empty parentheses. And even, back in '67, Simula had this right. There's no difference between calling a function and accessing a field. In the sense that in all cases it's getting some information by the object. And it should be possible to switch between the two, as here, without the client seeing it. So this is a small point, but it's a rather catastrophic point in the design of such languages. And the reason we can switch easily between a function for balance and an attribute, a field, for balance is the class invariant, which tells us that regardless of how we implement this stuff, the relationship between the three queries, deposits, withdrawals, and balance, must be as shown. So this is what we get here in this new version. A few words also about object-oriented analysis and how these ideas influence object-oriented analysis. There's a widely misunderstood notion of what object-oriented analysis is, like use cases, for example, which are an interesting idea but have nothing to do with analysis. And in reality, analysis is just, well, in the same way that design is programming carried out by Adam Eves, to cite von Clausewitz, or to paraphrase Clausewitz, analysis is still the same thing, but at a completely abstract level. And these ideas of contracts are just as useful, and perhaps even more useful, at the stage where you are describing systems at a very abstract level. This is an example from my book, Object-Oriented Software Construction, and I think it's as good as any to illustrate this point, that when you're modeling a system, then you can use programming constructs, in particular object-oriented programming constructs, just remove all the operational imperative stuff. And so, for example, in this matter of schedules for television stations, you can have things like there's a maximum interval between two successive segments, which is 2 seconds, the minimum duration of any segment, which is 30 seconds, and then in the invariant, things like the difference between the ending time and the starting time has to be at least equal to the minimum duration, and the difference between the starting time of the next segment and the ending time of the current segment has to be at most the maximum interval. So this is what we should be doing at analysis time. It's to describe our systems, our future systems, to model our future systems at a high level of abstraction, but precisely. And object technology with contract is really very productive here. Relatively few people have understood this yet, but those who have much more effective analysis documents, and of course the seamless transition to the rest of the software lifecycle. In a way, this is the exact reverse of model-driven design. The model and the design are the same thing. Okay, documentation. So I've made this point briefly before in response to Tucker's comment. The idea is that you have everything in the same place in the code, which also goes very well with some of the better agile ideas in this rehabilitation of the code. But it doesn't mean that the code by itself is the right documentation, as I'm afraid a few agile people would lead us to think. The code has far too much detail, and so after that we just use tools to produce various views, such as the ones I illustrated very briefly. And so the danger if you don't do this, the danger if you have this separation between interface and implementation, or between model and implementation, which is the model and program, which is the same thing, is what I would call the reverse Dorian Gray syndrome. I can also call it the French driver's license syndrome. So where it's the danger of divergence, right? So in case you hadn't noticed, well, it bears my name, so now by now you've probably guessed it. This is the documentation, right? And this is the state of the implementation this was 70, so 42 years, 40 years later, right? And this is exactly what happens with our programs if we keep the documenting and the documented separate, or the specifying and the specified separate. It is extremely difficult, and I would say in practice impossible, to maintain consistency. You can have all the management edicts that you want, but it just doesn't work because the software has this knack for evolving on its own. So the only way I know to maintain integrity is to have each piece of information in a single place, and then you extract the various levels of abstraction as you need. Okay, testing. Well, this is perhaps the best known part of design by contract. You can enable assertions. So here's my little example in Eiffel Studio. We have this notion of list. Or actually, let me go back. Yeah. So I have this thing here. And we have, so this is where I guess the picture that we had is useful. So we have this list with a cursor. So it is a routine force which advances the cursor by one position, and the cursor can, so this is the routine. I could also show you in Eiffel Studio, but it's bigger here. It has the precondition not after, meaning that when you're doing a force, you must not already be after. So the cursor can be between 0 and count plus 1, where count is the number of elements. So that's what the precondition of force says, and the postcondition says the new index will be equal to the old one plus 1. So here I have this thing here. The fact is the Tower of Hanoi irrelevant. I took some existing example that I had for my. So, okay, let me first comment this. And so we create a list, and so no bang bang, no double exclamation mark, and then it's a list of integers. So we add 3 values, 10, 20, and 30 at the end. Then we move the cursor to the first element. Okay, start. And then we do force and then force, and then so everything should be fine, right? It should work without any problem. And, well, it prints 10, which is the value, no, I'm sorry, 30, which is the value of the first element. And so now I'll uncomment this, so it's still going to be okay, right? So in the interest of time, I uncomment everything, and then it's going to try to go too far. So you're all well seated. You have a good insurance for the conference, because something is going to blow up, right? And well, you see what happens, or maybe you don't, because I don't know of any way to increase the font there, but it says not after, precondition violated, and so on the left you have the debugger, so you can traverse the object structure, find out exactly what happened. And this has been a fundamental tool for getting software right in Eiffel for 25 years. Okay? And I cannot emphasize enough how much this changes the practice of software development, in particular of software validation. So I can preach as much as I like, but until people have tried this, they don't believe me, and they get stuck with Roman numerals, but I would say it's their problem. Now this is what has been there for many years, and well, of course it keeps getting improved, but it's nothing new. What is really new in terms of concepts is the automation of all this. So some of you may have read a bit about, how many of you have seen actually Autotest, this tool? Okay, good for you. You still have kind of great revelations lying. I kind of envy you because I know this stuff. And so, you know, it's like meeting someone who has never heard Les Notes du Figaro, something like this. I mean, imagine not ever having heard Les Notes du Figaro or Don Giovanni. It would be so great. Unfortunately, well, so it's still ahead of you. There is this paper in IEEE Computer 2.5 years ago, and basically it's about automating the really difficult parts of the testing process. The difficult parts to automate. In particular, test case generation, that is not directly related with contracts, but is fundamental, it's necessary, and oracles. So actually, an observation here is that it always puzzles me to see that people are saying real programmers will never want to write contracts. Well, they don't. Some of them don't want to, maybe, and then they take JUnit, some testing tool, and how do you test? Well, you write assertions by the dozen after the fact. So why not do it before the fact and have all the advantages of better design, fewer bugs in the first place, documentation, possibly proofs, and so on. So so that's the difference. You know, we build our software with the contracts built in, as many as we can. You know, it's not an all or nothing approach. It's not extreme. And so what Autotest does, it's a standard part of the Eiffel environment. Nowadays, I mean, it used to be a research project at ETH, but now it continues as a research project, but it's now integrated into the standard environment, is that it generates all kinds of objects from all the classes under test, completely automatically, and it tries all the routines of these classes with, again, automatically generated arguments. And these 3 sentences I've kind of summarized, like 12 or 15 ISTA, ICSI, and so on papers. And then, so we call it test while you lunch, right? We push a button, go to lunch, come back, and find the bugs, find the post-condition violations, because the oracles are built in. Okay, so I'm running out of time, and I certainly don't want to be too impolite to the organizers, so I'm going to go to skip like 700 slides and go to, so yeah, maybe I can say a few words. Actually, I can use questions for, if I finish in 2 minutes. Maybe, so there's the whole thing about exceptions and inheritance. But I really want to go to my conclusion slides. Next time, give me 2 hours, or none at all, maybe, you know, depending on how. So, three or four final slides, and I really pity you because you don't know what you're missing with these, maybe not 700, but 20 or 30 slides that I'm skipping. Too bad. I really share the pain. So this is what we're doing at the moment at ETH and at ITMO in St. Petersburg. It's building this environment, well, it's called EIFO verification environment, but the slogan is what I call VAMOG, verification as a matter of course. And it's very much influenced by things like this boogie environment. I know I'm supposed to talk into the microphone, but I'm more a Mediterranean kind of speaker. I'm not very Swedish. In this respect, assuming that Swedish people actually talk here all the time. I don't know. So the goal, which was very much influenced by these efforts from Microsoft Research, but which we're making practical for everyday development, is to get away from verification as something that you do in very special cases for only very special systems and requiring a complete change of software development process. Instead, we want to have this programmer's assistant, which is like a guardian angel watching over your shoulder and verifying what you do using all kinds of techniques. We're very non-denominational here. Most people work on either proofs or abstract interpretation or model checking or tests, which is a completely different school, and we try to use everything that could work. We don't do much abstract interpretation or model checking yet, but we'd like to. So we have all these techniques, and they all collaborate. So you write your program, and as you write your program, all these checks get started in the background. Some dynamic checks, so auto-test that I just mentioned, runs in the background, you know, trying to find bugs, trying to find post-condition violations, but also the prover. We use Boogie for Microsoft for the moment. We might switch. We'll have more choices in the future. And so all these tools are kind of working in the background in order to help you, in order to come up with possible flaws or criticisms. And then once in a while, they report that they found something strange. And even better, we have some really interesting work on which we've started to publish in the past couple of years for not only finding bugs but suggesting fixes. It turns out that with contracts we have a really strong basis for not only finding bugs but actually proposing fixes. And I don't have the time to go into the details of this. It sounds a bit science fiction or AI or strange, but it actually starts to work. It's really starting to work. That is to say, in something like in our experiments, in something like between 1/3 to 40% of cases, we're actually on past bugs able to suggest the fix that was actually applied by human programmers. Okay, so to summarize, including summarizing what I have not said, what I would have said, but some which I did say, design contract includes both technical and management benefits. It's a more focused process. You know, don't neglect the methodological benefits. There's a sound basis for reuse. They didn't want to say Ariane. Exception handling, which I didn't talk about, guided by precise definition of what it means for cases to be normal or normal. Automatic documentation information generation, and lots of managerial benefits. In particular, benefit from the work of the best designers. One of the key problems for software project managers is to retain talent, or to retain at least the result of the work of talented people, even when these people leave, and that's partly what contracts are about. Design by contract provides a guiding metaphor throughout the software lifecycle. It's much more than just runtime assertions. It affects every aspect of development, management, methodology, language design. It's the part that, you know, the warning is that in the past 25 years, I've seen dozens, probably hundreds, and I'm not exaggerating, of proposals to add design by contract to all kinds of different languages and mechanisms, you know, from C++ to C, to Smalltalk, to Python, to Java, to UML with OCL and so on. There are a few that have survived, like JML, for example, for Java, and OCL for UML, although I don't know how widely it really is used. But I would say most of these are failures because in my experience, these concepts have to be intricately connected with and built into the fabric of the language. And doing these, introducing these mechanisms as a posteriori additions is really fraught with danger, so good luck. And in the modest tone that has been the hallmark of this presentation, I will conclude with this particular quote by Tom DeMarco, and I hope you'll be led to looking up these and other URLs which include much more information about the kind of things we do.
Okay, we are not running too late.
Okay, so kind of
but I think we have time for we have long breaks, which is very good. It's good for do some iPhone batching also afterwards. But I think that we have time for a couple of questions. So, who's first? John?
I always thought that dynamic contracts are a complete waste of time. As the pilot is coming into landing aircraft, having some information that tells you that the program has violated a contract about whether the landing gear is down or not, it's too late as everybody crashes and dies.
No, absolutely. So you're 100% correct. And no one I know releases an IFO system with contract monitoring on. It just doesn't happen. I mean, this is the kind of in introductory courses, people always ask this kind of question, or suggest that they could release software with contract monitoring on, but no one ever does it. So the dynamic evaluation of contracts is an outstanding mechanism for development, in particular for quality assurance. Okay? But it's not, I mean, I couldn't say it better than the way you did. Runtime is far too late to find out that a routine call violates a precondition. So that's only the reason why I've always considered personally runtime monitoring as kind of the second best technique. The real goal has always been static verification, and as I said, it's becoming realistic. I also had a few slides on this, so there's more to say, but that is the goal in the long term. It's static verification.
Which Spark has been doing for nearly 20 years.
Static? Yeah, sure. Yeah, but I mean, what is new is not so much the possibility of static verification. I mean, there were, Euclid for things, or ANA in the ADA world, which I'm sure some of you remember. People have been doing automatic proofs for even more than 20 years, for 40 years. What is changing is the realism of the technology, the fact that we are able to prove real things. So I would say there are two approaches there. I don't want to abuse my response time, but this is the second question, right? So there are essentially two roads that I see. One, which is well-traveled and very successful, is the Spark ADA kind of thing. I don't know if there's anyone from the Spark ADA community here, but I would assume. So this works very nicely. The big reservation there is that it's not for the rest of us. That is to say, most of us don't want to become monks. And who would want to renounce objects, classes, inheritance, genericity, dynamic allocation, recursion, and everything that makes it worthwhile to get up from your bed every morning? I mean, without these things, I would just remain in my bed, which is much more comfortable than my office. So it's completely justified if the stakes are so high, like human lives, that you don't have a choice. So the other, and that is possible today. I mean, the full verification, full static verification, if you're willing to make these kinds of sacrifices. So for those of us who are not willing to make these kinds of sacrifices and who don't necessarily have the privilege that our programs, if they don't work, will kill someone, then the other route is what's happening now. It's to build up proof technology so that it will handle real languages for real people with all these things that I mentioned. And the beautiful aspect, the beautiful part of living in 2012 is that it's happening. And it's happening with our work, it's happening with the work of Rustam Leno and his colleagues at Microsoft Research, it's happening with abstract interpretation. It's really what's happening now, and it's fantastic. So, you know, what was being done 20 or 40 years ago was great, but you could not apply it to real programs. And now it is starting to become applicable to real programs in real environment, in ordinary environments. So, long answer.
Yeah.
If you have to reflect on this, the most important non-practice, what do you see as the causes for the non in the sentence?
Look, there's something like what I had 7 billion people in the world, and I think there's like 6 billion, 9 million, 999 million, and so on people who are much better qualified to answer that question than I am. Because if I had the answer, then the comment would be wrong. So the plain answer is I don't know. I wish I knew.
Side note, I'm the current chairman of Bertrand that took over from the EDA group of the late assets that you found.
Yeah. You're Jean-Pierre Rosen, right?
Yes.
Yeah.
I have a problem with your handling with your view of exception. There was a requirement in EDA that if there was improper handling of an exception, it should not lead to an implicit loop with a retry that would not clearly pass that requirement. If you do a retry and you have not fixed the code of the exception, then you immediately enter an endless implicit loop.
Right. So maybe I should admit that before the talk, I secretly got together with Jean-Pierre and we agreed that he would ask this question so that I would get an opportunity to present my slides on exception handling. This is not true. This is not true. Well, yeah. So maybe you've seen this because I was nasty enough to quote it again in object-oriented software construction. And you know, either people who see this usually start screaming. For example, the return is not even syntactically correct because it should return something. Still, this is the way ADA exceptions were being marketed, so to speak. This is a textbook by Ian Somerville. It's not his software engineering textbook. It's another one. It's one of the early books on ADA. So, and I must say, well, yeah, I have to make a what? No, maybe not that. Yeah, I forgot on the side. I forgot to mention that another way to go from my original ADA example to the Eiffel equivalent is to get rid of all these totally useless semicolons, right? Simplicity is good. So end of digression meant to irritate you even more than I managed to in the previous hour. So coming back to serious stuff, so this is a routine. This is the example of ADA exceptions in that textbook. And a routine is a square root, and if the number is negative, it raises an exception called negative. And who handles the exception? Well, conveniently enough, there's a piece of code in the routine itself which handles it. And this is the nicest error message I've seen in my career, because think of this. Of an application, ADA was there to save, well, to Western civilization, right? If I remember right. And so, you know, what's a typical example of using square roots in a program to save Western civilization? It might be a trajectory computation of some kind, and it's really nice from the you know, if you think of the general who is starting this computation on his iPad, it's really nice to display this error message on the iPad of the general, you know, negative argument just before he's hit by the missile, which was actually meant for the other side. I think this is a really gentle consideration. So, yeah, in the early days, whenever I showed examples like these, and an ADA expert was in the audience, he would always say, we would never write something like this. Actually, as I said, it's not even syntactically correct because it's a function, so it should return something, right? Still, this is the way people have tended, many people I've seen have tended to use ADA exceptions, and what is missing, in my opinion, there is an analysis of what an exception really is. And yeah, so don't worry, I'm not going to show my whole thing, but only part of it. Well, much, but very fast. I'm very good at flipping slides quickly. So, yeah, there's a whole analysis of what it means to have in a normal case. And a normal case is a case that where you cannot specify the contract, so there's a distinction between the notion of failure and a notion of exception. And once you go into that analysis, which takes 10 minutes, but I don't have the 10 minutes, then the alpha mechanism follows relatively directly, and what does not follow is a use of exceptions as a control structure. In ADA, but also in common uses of Java or C++, there's a tendency to use exceptions throughout. To take, you search for an element in a table, you don't find it, bang, exception. And well, it's a programming style that some people like, but I think it's a misuse of exception. It's too much because it's a form of go-to that is even worse than the.
Think that.
Sorry?
We all think what you're saying.
Okay.
You
Okay.
need to make that point.
Okay.
Stronger.
Great. Great. So, yeah.
Sorry, Frank. Ben,
Do you still want your...
You had alluded to support for concurrency, and
Yeah.
you mentioned a little bit about what's involved in, perhaps if it does anything for real time.
Right. So, yeah. So the answer to the last question is very simple. It's no. We haven't looked into. I have looked into real time, but we have nothing to produce, to propose. Very quickly on concurrency, I use basically the part of my time that is not devoted to verifying programs to think and work on concurrency. It is this good mechanism which has been under development for a long time, which is not surprising me because all the major concurrency mechanisms that are emerging today go back to the 1990s. We just got a new boost as a result of this advanced investigator grant from the ERC. We're starting just now for 5 years. And so you are going to hear more about it if you still invite me, if anyone still invites me, of course. And so in connection with contracts, the basic observation is this. Assume that you have a routine which adds an element to a queue. And of course, the beautiful thing about it is that you can use it without having to know what the implementation is, and I do know that you all agree with it, so there's no need to tell me this particular case. So, for example, what I can do is this, from the outside. If the queue is not full, then put something into it because I'm satisfying the precondition. Okay. Now, this is the classical world, the current world. New world of concurrent programming, all civilization collapses. Everything that we believed in disappears because, of course, between the time I test here for the queue not being full and the time I actually take advantage of this knowledge that I've gained, and you could see that in the meantime my queue has become a buffer, right? We've moved from sequential to concurrent. That's the marvel of PowerPoint. But it's easier to do in PowerPoint than in the real world, because in the real world, between those two times, the time I test and the time I take advantage of the result of that test, someone can have come in, sneaked in, and destroyed that assumption that I was making. So I spent 6 months of my life, staring at this. They're trying to make sense of it. Because I had this mindset that, well, a precondition is a correctness condition. And it just doesn't work. And we had to realize at the end that it just doesn't work. So in the scoop world, preconditions as a result become weight conditions, and this is another 5 hours of speech that I won't inflict on you. So the concurrency mechanism is I would say, modestly simpler and more elegant than anything I've seen. But it still has a number of limitations. First, in terms of performance, the implementation is not quite there yet. We're working very hard on it. It's production, right? It's part of the release. It's not a prototype. It's part of the release version. But we can still improve performance. And to come back to your question, it does not handle real-time aspects yet. That is, of course, part of what we are planning to do as part of the concurrency made easy ERC project.
Last one.
Yes, on education. Do you teach IFL to undergraduates at ETH?
Yes?
What is your biased experience with teaching them pre- and post-condition and invariance?
Is the unbiased experience as well, acceptable as well as an answer to the question?
Yeah, biased is acceptable.
Well, actually, you're right. I'm biased. So, actually, the unbiased part is that I'm teaching introductory programming at ETH, which is something I did not expect because I'm coming from industry. I came relatively late to academia with this industry experience. The last thing I expected was to be the first face that these poor Swiss 19-year-olds who have done absolutely nothing to deserve that face see on the first morning or the first usually rainy day of the fall semester, as is going to happen in a couple of months, again from a couple of months from now. On the other hand, I've been doing it 9 times now, and the last 2 times in German, which is another, it's another story, and they still haven't kicked me out. So the objective part is that the factual observation, they have not kicked me out. Yeah. So this is connected with a fairly detailed analysis of what it takes to teach introductory programming today. I've written extensively about this. In fact, I've written an excellent textbook about it called Touch of Class, which is published by Springer, which I strongly recommend because I need to repaint my kitchen. And so it comes from I'm really trying to measure my words because otherwise it's going to be, again, another 2 hours. But it comes from an analysis which actually, again, goes back to the 1990s of what it takes to teach introductory programming today, which is very difficult because you get a really diverse mix of students. We have actually published our measurements, our unbiased objective measurements there. Roughly speaking, on the first day of class, this group of 200 19-year-old Swiss students, we get about 30% who have done a bit of programming, about the same who have done object-oriented programming. It's not going to add up to 100% because it's approximate figures. About 15% who have not touched a computer. Well, no, that's not true. Who have not programmed. They have all used a computer. But 50% who have not programmed at all. And about 15% who say that they have written an object-oriented system with over 100 classes, which, typically it's e-commerce sites, this kind of thing. So how do you teach to such a wide spectrum? And part of our solution is to use what we call the inverted curriculum approach. I published a number of papers on this in the past couple of decades, including some quite recent ones. It's the idea that we throw a lot of software, IFL libraries with contracts. It's a system that does, at the moment, simulation of traffic in a city. It can be programmed for different cities. And then we tell them to build programs on top of that. And one of the advantages is that it teaches them abstraction. By example, I can pontificate about abstraction like anyone else, but it doesn't work. It's like teaching these students to use condoms or something like that. They just listen or don't. So, on the other hand, if you see that you can make good use of 150,000 lines of code without understanding the details of it and produce pretty impressive applications that you can show the next weekend to your grandmother, then you start understanding the benefits of abstraction, APIs that are documented through contracts and such. So that's one of the major advantage. And just to stop with the second advantage, it addresses this issue of the incredibly diverse nature of prior backgrounds, because we can tell the novices to do exactly as we tell them, to go from the contracts and then little by little to see how it's done internally, which is this we call this progressive opening of the black boxes. You know, start or outside in. That's another slogan. You know, start as a consumer, and then little by little throughout the semester we tell them how it's done internally. So the novices follow this guide, this path strictly because they don't have a choice. But those who already have a lot of programming experience, typically in Python, Perl, Java, things like that, they are welcome to go ahead and start looking at the code and critique it and do their own and so on. So there's something to be gained by everyone, and it seems to work reasonably well, as I'm sure you'll be convinced of if you buy. Did I mention there's a book? So yeah, you should buy my book, Touch of Class, and then you'll be absolutely convinced. Actually, quite seriously, the preface of that book provides a fairly detailed analysis, as detailed as I could, of the issues involved in teaching introductory programming today. Yeah, sure. Thanks for reminding me of that. So the book is called Touch of Class, Learning to Program Well with Objects and Contracts, and it's published by
Thanks for Joe. Can I cut?